Welcome to JDesigner Tutorial 2, Modeling a Simple Branch. In this tutorial, we will study some of the basic properties of a simple metabolic branch and introduce the notion of a pathway flux. We will start Tutorial 2 with a branch model already entered into JDesigner. Let nodes 0, 2, and 3 be boundary species, while leaving node 1 as an internal species. Assign reversible Michaelis-Menten rate laws to all three reaction rates. The default values for the parameters can remain unaltered except for the Vmaxes, which should be set to 1.5 for reaction 1, 2.0 for reaction 2, and 4.0 for reaction 3. Set the initial concentration for node 0 to be 10 units. All other concentrations leave at 0. Before we proceed, close all open windows. Bring up the steady state control panel and table viewer. Compute the steady state by clicking on the Run button. Note that the output only shows a single item, the concentration of node 1, which should be at a value of about 0.031. We are now going to introduce the notion of a pathway flux. At any time during the evolution of a pathway, the rates for the different reactions as well as the species concentrations will evolve in time, eventually settling to some steady state values. The reaction rates that we measure during a simulation are termed fluxes. We can examine the fluxes of our simple branch very easily. On the steady state control panel, below the Run button, you should find the Edit Output List button. Click on this button to get the Output List dialog box. This panel permits one to select what attributes of a pathway one might like to view. By default, all internal molecular species are displayed. On the left side, one can see the kinds of attributes to display. In this case, we are interested in the fluxes. Click on the Fluxes entry and it should open up to reveal the list of fluxes. In the case of the simple branch, there will be 3 fluxes. These are indicated by the reaction names J0, J1, and J2. To add the fluxes to the right side of the panel, select each individually and click the Add button. Another way to do this is to click on the Flux button and hit Add to add all 3 simultaneously. Once you have completed this, click on the OK button and recompute the steady state. We will now try one final experiment which will investigate the effect of increasing the activity on the second limb. That is, we will change the Vmax of J2. Change the second Vmax from 2.0 to 6.0, recompute the steady state of the network. What do you observe? Compare the flux values with the values from the earlier experiment. Explain, for example, the change in J2. This concludes Tutorial 2. In Tutorial 3, we will investigate the basic properties of a simple cycle and introduce the idea of parameter scans.